Before we start talking about actually trying to solve systems of equations, let's talk a little bit about what a system of equations is. Okay, a system of equations is when we have two or more equations that we're going to solve essentially simultaneously. And the reason we have two or more equations is because we have two or more variables. However many variables you need to find is however many equations you need to have. And what we're basically finding as far as a graphing perspective is where the graphs are going to intersect, if they intersect. So systems of equations in two variables are looking at lines. So there are three different options for what our lines can do. We could have two lines that intersect in a single point. Okay, and we just have one value for x and one value for y. We could have two lines that are parallel to each other, which will never intersect. So intersect in one point, and there is one solution. We could have two lines that are parallel to each other, which means that they would never intersect. And there would be no solution. Or we could have two lines that are basically right on top of each other, okay? So we could end up with two equations that form the same line, which gives us infinitely many solutions, because every point on those lines would be a potential solution. Okay, so when we look at solving a system of equations in two variables, we could potentially end up with one solution, one value for x, one value for y. We could end up with no solution because the lines are parallel, or we could end up with lots of potential solutions. So the idea behind the substitution method, because we have two equations and two variables, we need to be able to rewrite this as one equation with one variable. So what we want to be able to do is get at least one of the variables by themselves on one side of the equal sign. Okay, which this is. So y is equal to 3x plus 5, which means that that 3x plus 5 can be substituted for the other y. So this y, I am going to rewrite as 3x plus 5. And that gives us one equation with one variable. So if we look at our equation, we have variables on both sides. So I want to get all the variables on one side. So I either can subtract 3x from each side, or I can subtract x from each side. And if I subtract x, it's going to allow me to keep that number positive. So 3x subtract 1x gives me 2x plus 5 equal to 1. And what? How about subtract 5? Yep, good, subtract 5. So 2x equals negative 4. Divide by 2. So x equals negative 2, okay? But we're solving a system of equations, which means we are going to find a value for x and a value for y. So we need to go back to our original set of equations here and pick one of them. I usually pick the one that has the smaller numbers. So y equals x plus 1, but it really doesn't matter which one. And then I'm going to put my negative 2 in for x. So negative 2 plus 1. And then just add the numbers together, so y would equal negative 1. So if we were to graph these two lines, they should intersect at the point negative 2, negative 1. So the second example is a little different because we have x plus y equal to 3 and 4x plus 4y equal to 8. None of the variables are currently by themselves. Okay, the 4x and the 4y, in order to get one of those by themselves, we'd have to divide. So I would definitely deal with the top one. We want to rewrite that so that either the x or the y is by itself. Does it matter which one? Nope. Anyone have a preference? Do we want x by itself or y by itself? X. X it is. So to get x by itself, from each side, we get x (3 minus y). 3 minus y is fine. Negative y plus 3 would be a little bit more technically correct, but for the purposes of this, I don't think it really matters. So we changed around the first equation to get x by itself. So now we're going to use the second equation to plug it in. Okay, don't plug it back into the first equation or it's just going to give you 0 equals 0. So I have x by itself. So in my second equation, I'm going to plug in what I got for x. So 4 times, I got 3 subtract y, plus 4y, and then I just copy the rest of the equation. And then I have to do some solving. What's the first thing I have to do to solve this? Distribute. Yep. So 4 times 3 is 4 times negative y gives us minus 4y, then plus 4y, then equals 8. So I get 12 minus 4y and plus 4y drop out. That gives us 0. So I have 12 equals 8. Okay. So my x or my y's went away, and I end up with a false statement. That means that this system actually has no solution. These two, if we were to graph these two lines, they would be parallel to each other. So if we actually get a value for y, if this was to work out, we got a value for y, we would take that value for y, plug it back in over here to solve for x, and we would get our two answers. If you end up with a false statement, it means that there is no solution. If you end up with a true statement, like 8 equals 8, you have infinitely many solutions. Okay?